I'm gonna wake some people up, aren't I? Well, this is New Jersey. We're in Hawthorne, New Jersey. Yeah, with the White Castle and the East Coast, and like Jay and Silent Bob and the Quick Mart, and Garden State with the lifestyle of the rich and the famous, and the MTV shows with the people from Jersey. All right, eventually you guys are gonna notice. So why are we in Jersey? What are we doing in Jersey? Is that weird? Why would you be in Jersey right now, Andreas? Oh, what's this? Oh, is this a Falcon? Does this say Falcon right here? What is this? Hi everyone. What is Falcon Hybrid Solutions? Is this ambiguous place? It looks so ambiguous. I'm just gonna go inside. We're just gonna check it. What's it like in here? Oh, look at this. Is this all? What is?
Oh shit! Sounds like we got a visitor.
Oh, Jeremiah.
Crooked Andreas,
Hey.
the legend, Xirtus. How you doing, buddy?
I'm the myth. Here's the reality right here. And we're welcome. What are we looking at here?
We are looking at hybrid battery cells.
Hybrid battery cells? That's a lot of hybrid battery cells.
Well, you should store a shed out back.
Why don't you wander us through a bit?
Yeah, let's just take a quick look.
Say
Well, we're
hello,
not here for
Jeremiah.
hybrid battery
Jeremiah,
business.
everyone, just in case that wasn't clear.
Hey, fellas, nice to see you. On his stream instead of just chiming in for a chat. It's pretty cool to actually meet this dude in person.
Dude, you guys actually, if you haven't already seen the alternative propulsion and anti-gravity video interviews that we did before, check out the podcast that we did with Jeremiah, and also watch Jeremiah the Technician's channel. He's got some cool stuff.
Yeah, we'll pop a few links in the description.
We're gonna
Well,
get
right
him on
behind you, we just finished putting that together last
Is
week.
this your monolith? Look at their monolith.
This is the monolith.
All right, so inside the monolith, this is what no one ever shows you inside the monolith. What do you got here? What is all this about?
Many banks of hold up 30 kV capacitors. Each one of these capacitors is good for 30,000 volts at 0.001 microfarads, and so they're just bunched up in these huge groups. And careful of the cord there, you're on that.
Oh my dear.
So there's a little depth trigger on this thing. And so effectively what it does is high voltage comes in via these wires down here. This is ground. This is our 30 kV input. It charges up these caps through a series of resistors. Now this device here, the whole thing is called a Marx generator. And when you pull on this black cord, a movable, another ball like these other terminal points in here, these spherical 10 millimeter terminals, it moves in and contacts like a switch. So this allows us to pull a handle and basically fire this entire thing. So here's what it does. It charges every one of these white capacitors up to 30,000 volts. And then all at once, by pulling that cord, it discharges them all through each other in series, stepping up the 30,000 volts through all these banks to a total of over 900,000 volts.
What?
And it then channels that energy out the top through this adjustable discharge arm, through a wire that's running along the top side, and then out of this terminal to produce a lightning bolt.
This is so epic.
I'm not going to open the thing up all the way at the moment, but what I can do for you, since you are here.
Oh man, is it actually, you've got it functional?
Oh, of course.
Oh man, it's already set up.
Okay, stand by. Ready?
Guys, careful. I'm behind.
Lightning. Nope, not quite yet.
I'm behind the wall
Hold
just in
it
case.
Just a tiny little bit. There we go. There we go.
Whoa! That was a snapper.
So that's basically what it is.
How much energy did you just put through that?
Right around 28 joules.
All right.
Here we go. 3, 2, 1.
Dude.
So when you need a lightning bolt in the lab, I mean, sometimes you do actually need a lightning bolt in the lab.
Yeah.
There's this legend that a fellow, who I can't name, was at one of his mines, and he happened to be present when a lightning bolt struck the ground, and he noticed that some small stone-like objects were floating above the bottom of the ground, and so naturally he waited for them to settle back down, being that they're lightning above, probably doesn't want to get struck, picked them up, and took them back with him. Then he sent them to a lab for analysis and discovered what they were. So we bought some of that material, and we've been hitting it with that thing to see what it will do. But that's not why we built the machine. We built that lightning bolt machine to test the Poplanov impulse discharge experiment which is a really interesting device wherein you discharge a stupidly high voltage at high current through a superconductor in a vacuum. And the superconductor, because of the junction between, well, it's not just a single superconductor, it's two superconductors sandwiched together with a layer between them that's slightly insulating, forming what's known as a Josephson junction. And so the magnetic field travels through the superconductor, gets caught up on the Josephson junction as electrons build up, and then they tunnel through in one huge event, producing a massive magnetic pulse. And according to the scientists that researched this, Eugene Popkanov, that impulse produced a gravity beam that shoots out the front of this thing. And when he built a very, very large version of it later on in his research, or so he claims at least, that that gravity beam was able to punch through walls and dent huge thick plates of steel and do all kinds of stuff.
The question is, what's more important? Is it the number of joules or is it the speed that it changes? So there's two different theories on this.
By the way, everybody, this is Mark. Say hi, Mark.
Oh,
Yeah.
Mark, yes, Mark from Falcon Space over
I
here.
really dig their shirts. I need to get one. Eat, sleep, propulsion, engineering. I think
I
it's
think that we
literally
should
been
make
our
our
life.
own, and I think that you guys already know exactly who to get it from.
yeah. We'll have to do some really psychedelics.
You know
Alternative
I want
propulsion.
one for sure.
We'll do the alternative propulsion and Tartaria stuff. All right. So what is
So
this
what's
again?
going on here? So basically, for this experiment, there's been two different theories about how it would actually work. Whether it's the high voltage that's necessary, or is it the amount of joules that's going through it. There's two different versions of the experiment. Basically, there's the Popkanov one where he just mentions high voltage. He doesn't really talk about the amount of joules that are in it, because you could have high voltage with low current or with low overall power. And then there's the Poyer version, which is tested by NASA, which actually works, which has more joules. So this entire contraption over here only has about 30, 40 joules of available energy when it's fully discharged. This capacitor, although it doesn't have 1,000,000 volts, it has 35,000 volts.
It's decent.
613 joules. You know what what's special about that number?
613. No, tell me.
That's the number of commandments in the Old Testament.
Oh, snap.
Yes. You want to hear something even crazier? So Jeremiah is buying these vacuum tubes for this from eBay for the Banduric experiment, and I was going to contact them because they didn't ship it on time, and I noticed that the seller is Green Girl 613.
Whoa.
Crazy.
Synchronicities, man.
The synchronicities.
Yeah.
Yes.
That's
We're going to
crazy.
punch 613 joules into that, and you know what we're going to use to do it? Oh, check this out. So this is the Thyrotron from the Berkeley Labs Linear Accelerator. This thing
Is
discovered
that the Berkeley? You got this? This is the.
from the Berkeley Labs Linear Accelerator.
Oh,
This
man.
was a component in the device that helped discover berkelium and californium.
Dude, Grandpa feels right hard right now. That's amazing.
And here's the.
And he got. He had. So how did you get a Berkeley linear accelerator?
They were taking it apart and they sold it on eBay. eBay is the anti-gravity, Home
It's
Depot.
like that Men in Black sequel. All right.
And check this out. These are the electronics that make the whole thing go. There's a massive battery that fits in here, and it's all controlled via fiber optics or laser through the side. There's a little hole over there, an optocoupler, and that all connects in with all the wiring. And basically, this is just a massive high-speed switch. And it's capable of 35,000 volts, and 35,000 volts is what we have available with our 613, what do you call it? 613
God, that's a beautiful
joule
tube.
capacitor, and that is one of the
Sweet
versions
613,
of the
right? Some Coral Castle stuff. I like your. You got kind of a Tesla coil kind of going here next to an electric car. Kind of sum you guys up, really.
Yeah, well, early on in the anti-gravity escapades. And,
You want to walk us through some more of the spot and show us some of the stuff?
yeah, so we're working on a lot of different experiments. We're doing also the Alzaphon experiment, which is dynamic nuclear orientation. That's this guy over here. First thing we found, Jeremy Reese actually found this piece of equipment.
Shout out to Alien Scientists.
Shout out to Alien Sciences. This is what got
Check 'em out on Twitter.
Alzaphon going into level 2, really. Because the most important thing that I needed for this experiment that I knew was hard to find was a high current, high voltage power supply. And this is capable of 5,000 volts, half an amp, meaning 2,500 freaking watts. This thing can really pump some power. And I need that in order to power a Thyrotron, or Klystron, which is this guy over here. it's a high current, high power microwave amplifier, and that's going through this whole device. This is for tuning of the waveguide, and it's all going to this little chamber where we're going to have very precise microwaves that are, in perfect sync with each other. We're also going to hit it with a magnetic field, a very laminar magnetic field of a specific strength. And what's going to happen is, according to the theory, we're going to have what's called EPR, or electroparamagnetic resonance, and we're going to pulse it at the Larmor frequency of the electron. So the outer electron in the valence bands is controlled by a magnetic field, because magnetic field is spin orientation, right? So everything's random, incoherent. You bring a magnetic field, it is coherence. Okay. Now what we're trying to do is bring on coherence for the subatomic level. So what we're doing is when you bring coherence to the magnetic field, they're spinning at the Larmor precession, which is the axis of rotation of the axis. It's a spin of the axis, basically. And that happens way up in the gigahertz range, which is microwaves. So you need to have a strong magnetic field, and then you're hitting it at the Larmor precession.
An aligned perturbance of the waves.
Yeah, you're pretty much you're energizing it at that precession that it's going over there, and then you release it. And what's supposed to happen is the orientation of the electron is then transferred through the hyperfine coupling, or the connection between the electron and the core, and that creates, that slowly builds up dynamic nuclear orientation, and then the craft becomes weightless, because once the core of the electron, the core of the atom is all oriented, the entire craft takes on the weight of one subatomic particle, and you're able to fly off with just a tiny bit of thrust in the other direction.
Pretty sweet. It's kind of like removing the dimensionality of the electron itself. You're
taking the electron as a stepping stool to get to the core of the atom, because the core of the atom is where all the mass is. That's where our inertial mass comes from. So if we're able to control the core of the atom, where all the energy is and where all the mass is, and get it oriented just like the magnetic field is oriented, we can become weightless. We can become, it's basically nuclear magnetism.
This is the
electromagnetism. We're doing nuclear magnetism over here.
This is the new diet. This is how you lose weight the real way.
No, hey, let's make you lose weight. Lose weight, you need to drink less.
Just in general.
Yeah, you just need less
Really?
calories.
Yeah. All right.
That's the way to go.
Do we go through here more, or do you want to show more? You've seen some of the batteries. Those are pretty sweet.
Oh yeah, here's the Faraday cage.
Oh boy. I was just standing like, where is it? Oh, there. How about... It's not going to let me film inside a Faraday cage, huh? It's going to, destroy the cell phone's going to lose its... Oh, it feels good in here, though, right?
One second, I'll turn on the lights.
Whoa. I want... Here. It's going to...
Oh, it should be working. Are you on the Wi-Fi?
No, not yet. I'm just using 5G.
Okay, the 5G is going to drop if I close the door.
Let's show it. It'll turn back on afterwards. Let's just see how... If it turns off... Come back! Oh, that was...
Okay, yeah.
That always should prove that it works, okay?
Yeah, the Faraday gauge works.
That's what you wanted to see, right? All right, and then
we got an experiment going on right now. We can't touch it.
Yeah, you gotta be careful. There's another Andreas and Mark in there right now from a Prime universe.
We're not going to talk about them. You can't affect the timeline.
It's basically just me with a mustache. Don't worry about it.
Oh, check this out. Here's the Enterprise.
Yeah.
It's in space dock, as you can see.
Her Majesty's ship. It's been a long time. No one ever likes the Enterprise theme song, but that's my favorite. Faith of the Heart.
I love that song. Yes.
You're crazy.
I actually woke up Jeremy Riss one morning. Actually, it was at noon, pretty much. We were waking up from a night's work, and I played that in the morning, and he woke up and was screaming. He was like, "Why? I didn't even know he was in the house," and he was like, "Who listens to Star Trek in the morning?"
You gotta check out my cover on SoundCloud. I got a pretty ridiculous.
Awesome. I was thinking of editing some of the videos to Star Trek things.
Oh, they're gonna make Captain Archer the president of the Federation in a new series they're talking about right now.
Yeah?
Yeah, they want to do Sausalito as the capital.
Okay, so here's the lab, or the build it shop.
Alright. As we walk in, let me flip around. There we go. So this is where it gets really busy. This is where you can tell gentlemen do get to work. There's a lot of stuff going on all the tables.
Mm-hmm.
This is pretty epic. What's this?
Oh, this is
There's
this is
science
the Vimana
in the
engine.
air.
Science in the air.
Yeah.
This is the Vimana engine that we're building. So this is actually prototype B of this device. Prototype A has been taken apart for parts. Basically, what we were trying to do is create a device that sort of like swims when the gyroscopes are turned on. And I had all 4 of them set up before, and it worked on the pendulum, but it was starting to fall apart, so I had to rebuild it in a stronger fashion, and I added a second axis for each of them. And it's all being controlled via remote control, and we have a programmable remote control over here that we were using to...
Tech.
Yeah.
Pretty
The
sweet.
9XR, it's a pretty programmable device, so we're basically creating a remote control Vimana device, and if that works, it will explain how you can get a little bit of thrust, with in conjunction with the dynamic nuclear orientation, can take you to the stars.
So you can like program like paths with this thing, huh? Like you can do like.
Oh, you can do a lot with that
Whoa.
thing. If there's anybody on your channel that knows how to program this who can give us a hand, that would be helpful.
Dude, there probably are, because like there's like RC helicopter drone pilots, and before they had
The
digital.
9XR, if anyone's like a professional on this, like give me a call because I got a lot of questions on how to set this up.
You know, like before they had all of the drone software figured out that it was super smooth flying, you had to get a guy who knew how to program one of these things to do a sine curve in order to have something do like a perfect fly pattern for video and stuff.
I just want it to be able to like, you flick one switch and it does a certain program and just like goes back and forth, do, or something like that.
We need that. We need some help with that. That seems like a good deal. All right. And then what's this pressure?
Oh, that's a vacuum chamber. We use that all the time.
Are you making your epoxy? What's it for?
Yeah, it's mostly for like airing out epoxy, and
Nice.
We could do experiments in it, but we haven't done any actual experiments in it. It's just been a functional device at the moment.
Dude, I noticed ever since we did the talk that they started getting into like electro epoxy, conductive epoxies are getting really popular. Like everyone, Spectrum magazine, IEEE, everyone's kind of getting into the different ways that you can make electro epoxies and.
Yeah, I wonder what the dot product of that type of material might be. I bet you it's odd.
They're doing a lot of interesting nanotech with electro epoxy. That's going to be, especially when batteries and if you can do designs that you can allow for photonics and.
I think the technological possibilities are going to be almost endless. If epoxies and other 3D printing methods get good enough, say that you can actually lay out a light blocking material and print in fibers for optics and communication, you can effectively design systems to do just about anything. And I guess at that point, the only real limitation comes down to precision.
Yeah, I mean,
And
so that's,
efficiency, of course. I should also mention it probably does also include efficiency, because clearly a 3D printed fiber is not going to have anywhere near the optical efficiency or the power threshold of, say, an extruded glass fiber.
Well, they're working on this phaser quality that you can have multiple potentials reached at the same time. And so if it's kind of a quantum state, man. So you've got like 5 different functional, and this would be useful in like fabric. Because if something can bend and then some of the patterns don't, they destroy the current or the path. Other paths still make it, and then from there it can kind of infer enough 90% of the signal.
And now think about what we have. I mean, we had plastic 3D printers, and that was revolutionary.
Yeah.
But the very first 3D printers weren't plastic; they were still resin printers. And
Right.
if you take a look at the early machines, $500,000 resin printer machines, egregious price, but for a laboratory that was pumping out tons of parts and constantly engineering their own new prototypes, to be able to fit that straight up from the lab into the assembly line and see if that part would fit and if it would work, I mean, that's almost invaluable.
Right.
So, and now what we have, we can print metals.
Yeah.
We can print plastics. We can
And
print
we have
fibers.
better
we can
porcelain.
Print,
The porcelain ceramics are so much better than the glassy porcelain ceramics, and you can
Right.
put in conductive materials into ceramics. So conductive ceramics are going to be crazy.
well, we can print buildings. I
Yeah.
mean, for God's sake.
But I mean, that's crazy. Conductive ceramics.
Conductive ceramics are going to be, yeah, printing your capacitors into the circuit board that you just printed is a crazy, wild idea. And if you take it to the far stretches of the imagination, printing your semiconductors, nanolayer by nanolayer, straight into the whole assembly, I mean, basically your circuit board, the entire circuit board just becomes one monolithic chip. And
Yeah.
all you have to do is supply it power and the inputs it needs, the external world, and you've got yourself an almost indestructible circuit in terms of its mechanical resilience.
It's like solid state physics at its finest.
It really is. It's going to revolutionize the way that technology is made.
Nerds. Okay.
You
so
know,
let me-
absolutely, and proud of it.
ways to meld well, to bring metals together than currently going on with 3D printing.
Absolutely.
3D printing is definitely very important. It's being used in aerospace because now they can make shapes that they were never able to make before with certain strengths. But there's certain materials that are just going to be out of its reach because of, you need inert atmospheres, or doing it in outer space, or vapor deposition. There's certain techniques of building materials that you can't really do with a 3D printer. But
Yeah,
it
I mean, they
definitely
need.
has its use.
There needs to be better lens resin printing for metal stoichiometric bonding, because right now the bonding is like really haphazard, and what we want to be able to remove a material while a lens is creating a specific kind of bond between the metals using maybe, and this gets back into like electromagnetic flow of the ions to make sure that the metal is aligned in a certain way. There's a new crystal that they just discovered in Israel that is it's better than diamonds, new carbon structure.
Oh, I noticed that. I haven't read up on it too much. I've been too concentrated on this stuff, but there's some sort of crystal. I'm not sure if it's real or not. I've never heard of this
I don't know if
before.
it's natural or not, but I'm pretty sure it's real. I think it's like it's a mathematical structure that's stronger than any other carbon bond. It's better than graphene or diamond. It's crazy.
I'll have to look into it a little bit more, but what I can tell you about diamonds is that the diamond shape is not the strongest material of the carbon structure. There is a more rigid structure when they compress diamonds, and what happens is the bonds just dive in on each other and become sort of like, instead of being hexagonal, they're all facing inwards on each other.
Oh.
On one like center point, and that material actually is a superconductor of heat.
Nice.
It's a heat superconductor. So that might be a useful material in any thermal electro device, like heat directly to electricity. And we were talking about this the other day, actually, with about Brownian motion, a Brownian motion device that can turn Brownian motion, which is essentially heat, directly into electricity. Jeremiah, remember that conversation?
Oh yeah, it was quite
So
extensive.
how does that differ from piezoelectric generation?
Piezoelectric requires a mechanical force across the entire crystalline lattice in order to produce a net output charge. Brownian motion is just simply the natural motion of the fact that atoms and molecules have some kinetic energy to them, which we call heat. When you think about us, we're 500K above absolute zero right now. Or not 500, but anyways, it's pretty freaking hot here on Earth compared to, say, if there's no atomic motion.
I think we're about
happening.
300.
300 something.
300 above absolute zero.
We're doing pretty good for not being Kelvin beings.
But if you consider, the difference between this, where we are on Earth right now, the temperature here, and the temperature if there was absolutely no motion, there's a significant amount of energy difference in there. So even a temperature converter like a thermocouple junction, if you place hot on one side and cold on the other, it causes a flow of electrons through the dissimilar metal junctions inside of that device. And so you end up producing electricity because of a difference in heat, not just because of heat present alone, because you could stick the whole thing in an oven and it wouldn't do anything because it's hot on both sides. But if you make one side cold and one side hot, you get a flow of current.
And that's the kind of device we're using on Mars to power, like Voyager 1, Voyager 2, and the Mars probes. Right?
But when we can take this...
nuclear in the center, and then it just can dissipate heat slowly. That's how we're doing thermoelectric devices. But there's other versions of that.
Right. Now, if we take Brownian motion, Lord Kelvin said that entropy will cause a continuous increase in chaos, and there's no way to ever convert thermal energy once all other energy forms are converted into just simply the kinetic or motion energy of molecules or atoms. There's no way to ever down-convert that or put it back into some kind of usable mechanical form. Well, Lord Kelvin has been proven wrong because there's about 50 patents out there right now that tell you exactly what they're doing in order to achieve that. And so they're able to take very small motions. It's Maxwell's demon, the impossible physics equation. Maxwell's demon is an interesting thought experiment where you have a bunch of air molecules or a bunch of molecules bouncing around in two sides or two different boxes, and the boxes have a door between them. And the demon basically can look at which molecules are about to hit the door, and the demon can open up the door and allow a molecule to go from one box that's moving already in that direction and enter the other box, but then close the door immediately behind that molecule so that you don't end up getting, you end up with more in one box than the other, which should be technically impossible. But it's a thought experiment, and it's interesting because it is theoretically possible in that context, mechanically at least, to allow gating, like a diode, to allow momentum or kinetic energy, thermal energy, to flow in one direction but not the other. We have electrical energy devices that allow electricity to only flow in one direction but not the other. We have mechanical devices that allow air, water, and other fluids to flow in one direction but not the other. We have very interesting Casimir devices to allow tiny little microwaves or radio wave fluctuations to flow in one direction but not the other. And we even have SWR matching equipment to allow microwaves to go through a beam guide. Isolators,
Yeah,
which are
microwave
effectively
isolators.
microwave diodes. So if
Wow.
we have all these devices that can effectively rectify the flow of an energy source from one direction to the other, but have a different amount of energy in backflow in the opposite direction, why not thermal energy? It's just hard because it happens on such a small scale. It's atomic.
So like we're thinking like nano generators then basically.
Well,
that
these
running
these
off.
are literal atoms bouncing around.
Yeah.
And if we could just take the atoms that are moving in the direction that we want and use their energy, or the molecules that are moving in the direction we want, and just use their energy, but ignore all others,
with the flow.
effectively, we can take that energy and convert it into a usable form that we want. So
Basically, we're talking about building a device that will, as you suck energy out of it, it will just get colder and colder. So you need to provide it with heat, and you can suck that heat out of the atmosphere, out of the earth, or wherever there is a source of heat. But if it goes down to absolute zero, it's not going to have any power output anymore, or wherever the efficiency stops for it.
So Lord Kelvin could tolerate it because the conservation of energy is maintained in this system. It's just that it's being done in a way which he thought to be impossible, which we're now finding now in the 21st century is actually quite feasible. I guess we're quite... it's actually becoming quite feasible. Now, of course, it's incredibly complicated, and we're nowhere near set up at this laboratory to do it yet. But we're considering the concepts because I think it's going to become important later on when we talk about how to generate power in deep space. We don't have solar, we don't have other sources.
You do not want extra heat flowing off inside the craft.
So
Yeah,
what
It's going to get hard to radiate heat.
what are your current
Too
main goals for the alternative propulsion engineering lab? What are you guys
Conference.
trying to get? What is,
It's the alternative. I guess it's the alternative propulsion engineering.
yeah, I mean it's
Well, it's sort of become that. I mean, after all,
yeah.
this is
It started
all
as a con and now it's the whole thing. Yeah.
Well, our main goals are to take the alternative theories, which are thought to be impossible by the conventional old-school physics, Newtonian physics, for example. Many things there are supposed to be impossible that Einstein allowed now the possibility of. So we understand gravity in a much greater extent than we ever have in the past. We are really getting a grasp on what this gravity thing is and how it supposedly works. And we're understanding that it's not, the word gravity is sort of a misnomer. It refers to something that's a lot more complicated than just the force. And just to say, something is pulled down towards this planet that we're on, the surface that we're on, it doesn't matter because we want to understand what that is, why it happens, and exactly how to manipulate it. Now, if it was true that we really understood this force, the fact is that we would have vehicles to utilize it that didn't have to require the motion of other physical matter in order to propel themselves. This would be rockets, airplanes, anything that basically pushes against a physical material in order to accelerate itself. Well, these devices are conventional and they're Newtonian. You have an equal and opposite reaction. But relativity offers us an interesting perspective to open up an idea like this. You can have a different equal and opposite reaction between both sides in frames of reference, but when you take the whole system altogether, you don't have equal and opposite. You have an asymmetric direction, a pointing vector. And this is because two different sources of equal energy in two different frames of reference can actually appear to each other as having two different levels of electric charge, or two different strengths of magnetic field, or two different amounts of mass, even though technically the two objects are exactly the same if you were to look at them. And this is what relativity offers us, is the possibility to break that frame of reference, to divide a system from 1 to 2, and through that duality we can produce a force that's not equal and opposite. And it doesn't require us to push propellant out the back end of a rocket or to push against the atmosphere. This allows us to produce a force straight against the reaction of the physical space itself that we all exist in. which is a kind of interesting concept. And so that's what we're really trying to prove, the possibility of that.
Sweetness. What's he doing over here?
We're building the Vimana engine. So this is the gyroscope that's going to spin it back and forth. And these are basically pieces of PVC material that we got out of Home Depot, and we're just going to be gluing them together.
Epic.
Oh, shit.
All right, I'm gonna check some of these comments. There's like a few going on here. All right. Hello, everybody. How's it going? It's a taco shop, says Hype. No, it's an anti-gravity taco shop. Flying taco.
The flying taco.
Electricity time. Vacuum tubes suck. That's good, right? What about anybody?
I agree with that. Vacuum tubes do suck, but there's a very specific reason why we're using them.
No, they meant more literally.
Oh, literally.
gosh,
Oh,
yes.
man. Even trolled us. Way to go. I'll give some cred for that comment. That's a winner.
We all liked that one. All right. Xirtium.
You got us.
Tartarium. We should start making some elements ourselves, it's true, or at least some compounds. Make the loudest doom metal tube amp. Plug it in. Mercury vortex where it's at. That's what I heard. Okay, so that's something we're gonna have to get into, by the way, is the
Yes.
Mercury vortex thing.
In fact, was it not the Mercury vortex discussion?
Yeah.
Indeed.
I'm gonna just really quickly check to make sure I think we should go there. That's the first thing we gotta go to. 3D
Yeah.
print star forts. Yeah, okay, cool. All right, so Mercury, let's talk about that. You guys, go ahead, just go back to where we were earlier, because we were just talking about that.
Mercury vortex engine. Basically, what we think is going on there is there's some sort of connection between spinning inertia and linear momentum, like that you're able to turn spin into linear motion somehow. And when you look at a gyroscope, you see lots of things happening. There's the spin of the gyroscope itself along its axis, and then there's the spin of the axis around whatever point you have it sitting on. But if you put that all inside a tub on a platform on one end, you'll see that the platform itself will spin in the same direction. So I was thinking, what would happen if I put two gyroscopes apart from each other, spinning in opposite directions, precessing in opposite directions? Would that create forward momentum? And I thought that out loud at the APEC conference, and this guy got on, Mike Gamble, and he said, "Oh yeah, that will work. Here's my device," and he pulls it out, and there's two gyroscopes
He
there.
just has it ready.
And he just
I
had
love
it
that.
right there on the on his desk. It was just amazing. And he was like, "Yeah, it works." And then we started talking about it for a little bit. And he showed how it works on wheels, but it doesn't work on a pendulum. And he says because it's out of sync, it's just swinging around. So
Yeah, not
my thought
necessarily,
immediately
you know.
was that
grab a chair.
maybe all you
Yeah.
need, instead of two gyroscopes where it was out of sync, maybe you could get four of them and make it in sync so it won't swing around. So I built this device. We built prototype A. It worked, but the prototype was falling apart. And then, sure enough, I'm rebuilding it right now. We tried it. I only rebuilt half of it. So we have two gyroscopes that are working, and I gave them two axes of motion this time. And they are, with just two gyroscopes, no matter what I do, I couldn't get the thing to move around. But it was shaking like crazy, like he said. And the first test we did wasn't shaking like that. So we're trying to build the last two gyroscopes right now to add it to the device, and then we'll be able to remote control it and see if there's any specific motion that we can put on these gyroscopes that will elicit a response.
And so you were talking about using liquid mercury for a vortex pattern, right? And we were trying to figure out what the correct shape would be to do that.
Yeah, I think the two experiments are pretty much linked, because I think the reason for using mercury is to just because it's a heavy material. There may be some other reasons. I know it's possible to get high voltage out of it when it's spinning around, and it also is a thermal to electric converter, but it's a potential thermal to electric converter. But the spinning vortex in the center kind of brings up the gyroscope idea. We do have mercury available, and we can create any kind of like spinning device with mercury in it, but we just want some satiant theory as to how it is that we should shape these coils, because it's pretty difficult to make a coil of mercury and have it spinning around.
So one of the things we did the other day, just playing around, took some of the mercury we had in stock and stuck it next to a rotating magnetic field to see how much we could really influence its motion. And it turns out that it's very, very easy to rotate a large mass of mercury inside of a closed tube using an external magnetic field. It grabs right onto it, and the eddy currents are more than sufficient to accelerate it. And since in our mercury vortex engine, ideally we would have a heat source that got the mercury to the point where it's just about to boil, and by controlling the pressure in the system, we can cause it to boil and become a vapor in one part of the system, having a very high acceleration, a very high relativistic velocity compared to the rest of the mercury in the system, and then recondense back into a liquid on its return path, so that it has a slow motion in one direction and a very fast motion in the other as a vapor. We could effectively control it. And the great thing about using magnetic fields to propel it is the eddy currents will actually cause it to heat up, which is already a function that we need it to have. So it's a very nice possibility of constructing a system, and it's something that we intend to potentially try and build, which we haven't seen done so far.
I think it's it's another thing, guys. Please make some comments about your thoughts on Tartarian shapes for the liquid mercury, because I think that's something you guys have studied a lot. I'm gonna talk to Stellium and 13th Monkey a bit about that as well, because I think that might contribute to some of the futurism that is going on here.
So is it really futurism or just digging back into the past?
A lot of the time.
Do you think it's the speed that the mercury goes in one direction versus the speed that it returns that creates the effect? And
Absolutely. Just like the gyroscopes, it's the fact that one side of it relative to the rest of the planet that we're on is moving very, very fast, but the other side is moving much slower. Just sort of like a wheel rolling along the ground. As that wheel rolls along, one side is at absolute rest in comparison to the ground, but the other side is moving at twice the forward velocity of the rest of the vehicle.
And therefore what?
Therefore you have a general upwards force, because that outfling of that higher momentum, the higher speed mass, it actually has a different mass in motion in relative comparison to the Earth. So you actually have an upwards force on wheels.
So you're trying to bring up the concept of momentum's non-linearity.
Right, as a result of its velocity relative to a stationary observer's frame of reference.
Ultimately, if you have a closed system of mercury, the amount of mercury going down and the amount of mercury going up needs to be the same. The only thing you can change is the relative, the small amount of mercury that's coming down. You can make a small amount coming down very rapidly and have a large amount going back up on the sides. That's the only thing you can really change.
Well, it's not even necessary to have the same amount going up at the same time as as the full mass. I mean, you don't have to have 10 pounds of mercury vapor going up and 10 pounds going down, but you just have to have an equal amount of mercury going up that's returned back to the bottom path. Right. So basically,
yes, it needs to happen at the same rate. Otherwise, you'd end up with overload on one side.
It's really kind of like a lightning discharge. In this case, you have current flowing very slowly through the wire that actually delivers the power for the lightning bolt. But the lightning travels incredibly fast. So the electrons, they don't really move fast through a wire in a synthetic lightning generator like we've seen earlier, but they certainly move incredibly quickly through the air. The leader electrons move fast, and the plasma is quite conductive, and it has a high electron transit velocity, a high drift velocity. Plasma is a great drift velocity initiator compared to, say, solid copper. But nevertheless, the electrons are flowing at different speeds in that circuit, yet the same quantity of electrons that enters one part of the circuit eventually exits that, and you always have the same quantity of electrons as a net total in that circuit.
Okay.
They just move at different rates.
This is always fun when people talk about electrons, because I think that's becoming kind of a this is the metric that we're using, Yeah.
To say electron isn't to say that we agree with the conventional viewpoint of everything that an electron is. It's just a nice word to say this thing that exists with a negative charge that seems to be the contributor or cause of electricity.
Why is it a negative charge? Why isn't that
because it's an arbitrary label that we gave it, and it doesn't mean anything.
Positive.
Well, it could be positive, or it could be negative, or it could be Yorp.
I mean,
it doesn't matter if it has a York charge or if it has a salt charge. It's just a word that we use to describe it.
But in the human psyche, when you say positive, you're thinking of adding, you're thinking of plus, you're thinking of more. And to say that the electron is negative, meaning it's less,
I do agree with that.
I think that's backwards.
Linguistics, it makes more sense.
That's why I was saying that.
It shows that the electron started out as not an object, but as a dimensionality.
No, it's started out as they didn't understand what was going
Well,
on.
that's
And
I
they
still don't know if
already
we understand
labeled-
what's going on.
They already labeled something positive, and then they discovered the electron. They realized, holy fuck, we got this wrong.
well, but it's
At that point, they should have changed it. That was the mistake.
it's positive because that's
That
where
was
things
the opportunity
flow.
to change the positive.
The
and
positive
negative.
side is where things flow to. You know, it's like me.
No, but the electron's what's flowing.
Well, that's why it could be. You know, it's yeah, but I still think it's positive.
Do you know
for
what
reasons.
pH is?
The pH scale? Or?
Yeah. What does pH stand for?
Oh man, I forget now.
Potential
Yeah,
hydrogen.
potential hydrogen. Yeah,
Right.
sorry.
So electricity is potential electrons.
Oh, okay.
So positive on the scale of hydrogen is 13, right? 14, 15. Negative is no hydrogen. So that should be the same with the electron system.
Huh. All
Yeah,
right.
it is a kind of backwards approach the way that we used our labels.
Yeah.
It's just language sucks, man. It's an interesting human phenomenon to study, to make audible mouth sounds or visible physical gestures to animate an idea. Language is just a strange phenomenon, and it really sucks that we actually have to produce a physical fluctuation of the environment to communicate an idea from one brain to another instead of just thinking it. Wouldn't it be much more convenient?
Well, all right. So somebody remind me, because there's the bald guy with the tattoos who does his physics videos, and he says everything's a hoax all the time. You guys have seen him, but he says he's the guy who's talked a lot about waves perturbance. I need to get that.
I'm not even gonna say that guy's name.
But you know who it is, right?
Yes, I do.
Yeah, there's-
Not a fan.
Yeah, he annoys me too. I'll admit it. Let me see if
Who
anyone's.
is that guy?
Oh,
Nope.
you don't even. Yeah, don't worry about it. But like that idea though, still. I mean, the thing is that really all that bothers me about him is he'll say everything's a lie, and then he'll have a video saying he'll explain it, and it's just an hour of him saying it's a lie. He never gets to the point where he explains what he's
Oh
trying.
yeah, he has a video called "How to Build a Ferrocell," and in that video, he doesn't bother to show you anything about how to build a ferrocell. He spends the entire video
Yeah.
bragging about how he built his ferrocells, but not actually telling you how he did it. He says, "Oh, I built this, and this is great, and this is what it does, and it has this thing in it." There's nothing being assembled in that video.
Everybody's got a ferrocell.
We actually did build
Yeah.
ferrocells, and they were not that difficult. We took apart LCD TVs because they have these little microbeads inside of them that are spacers between the two glass panels in order to keep the liquid crystal at the exact right thickness layer so that it can fully twist and block the light. And we use those microbeads to separate the two pieces of glass that contain the ferrofluid for the ferrocell. And it worked great. It's not hard to build one. Just two pieces of glass and some kind of very, very thin spacer between them filled with ferrofluid. That's about it. Well, ferrofluid thinned out with oil, preferably. And now with
Where did you get your
WD-40
ferrofluid? Did you just order it? Or?
Yeah, I just ordered it online. It was cheap eBay ferrofluid. It was also terrible because it wasn't
eBay.
in good suspension. I bought it on eBay.
Of all things, though, yeah.
Dude, eBay you can get almost anything you need. It's
Tickets
used
to
stuff
Valhalla. Yeah.
and there's a lot of rejected stuff that society no longer has much use for, but in the right hands,
What's
you can
tickets
do
to
a lot with it.
Valhalla?
I sold tickets to Valhalla when I was 13 on eBay.
Oh, these
I
are
was like,
sweet.
This I put in the thing. It does not actually promise that Valhalla exists, but if it does, these are tickets to Valhalla. And for a while, you could sell stuff like that on eBay until eventually they were like,
Sweet.
"This is crazy." Now, yes. Now, if you look at anything through rainbows, this
Yeah,
is-
buddy, it's the future now.
yeah.
All right, let me see again.
I wonder what these do with lasers.
Pretty sweet. Watar, Scott. Watar.
Laser.
Yeah, let's find out. Well, that looks like our diffraction pattern.
Oh,
there.
that's epic.
I wonder if people can. You want? You guys want to wear the glasses? Here.
Yeah, dude.
We'll put
Put them
these-
on.
There you go.
This is crazy.
Oh, that looks great.
Well, now it probably looks really crazy.
You guys are gonna need to get some of these glasses.
They're pretty sick.
Pretty sweet.
If you did want to know the chroma of any particular light source, these will show it to you. It's actually kind of a convenient way to view the chromatic spectral spread of any particular light.
When you're driving, they like actually give you more depth perception because the light breaks apart and comes together when you get close to it. So you're like, as you get closer, the light gets closer. So you're like, it gives you About 90 feet extra depth perception. It's pretty sweet. Depending on how fast you're driving. Sweet.
These are pretty cool.
Yeah, enjoy. I got a few pairs, so you
I
can.
like that they got your brand on them, man. Tartaria all the way.
Dude. Well, all right, guys. It's been about 45 minutes, and I think we're gonna do more videos tomorrow. Is there anything else that we should show them in the lab? You think?
Well, the only last thing that will be the big thing that I'm excited about, the Banduric replication. This will be a very important piece for field propulsion science if we can fundamentally prove it out. We've done over 20 tests on it so far, and this device in conjunction with an isolated power supply here.
Is that the Batman CD player? What does it do?
Well, it spins, and as it spins, it produces a relativistic difference in the electric fields between one side and the other.
Oh.
And as a result of those fields being different, there's a net force produced in one direction, this way, which is opposite the direction of airflow that it should be sucking in from this side. So this thing should be pulling itself like this, but it actually pulls itself like this because of the relativistic electric field difference, and it does this isolated from everything else, which means no propellant.
Dude, you're gonna have to show me that later.
Yeah, that's the big test, and we are still trying to prove this out. There's quite a few more things that we have yet to do before we can fundamentally demonstrate that this device is doing what it's supposed to be doing, and that it's not some other effect of airflow, ions, or anything else. And the way that we're going to do that is by sticking it inside of a box. One, a plastic box, and then second, a metal box. And if we can do that and it still operates in both those environments, it shows that we can put this effectively in a satellite in space, and with no propellant, it would produce a force and move a satellite along. So this is Richard Banduric's invention, his device that he publicly released and told everybody basically how to build in a very nicely assembled PDF manual. So we're replicating it, and since we haven't seen anybody else actually attempt to do this in the full fruition of what it is and what it's supposed to do, we're going to test it. Because we have to. We have to know. That's science.
Pretty sweet, guys. All right. Well, all right. So expect us to do some more videos pretty soon. Like, I think tomorrow we're gonna do some more, and like we might actually go back on and record a bit more of our conversations. But just wanted to give you guys this as a piece that you can observe, and then we'll go on to the next as a chapter. So thanks for watching. Talk to you all soon. Alternative propulsion is no longer just an engineering conference. It's now a laboratory. Keep winning.